And hello, everybody. We are back to Days Post-Apocalyptic World / The Origin of Life / it's just been changed to Homestead High. So hi to you. And our little mascot here, Nebula, says, oh, hello also. She happened to be on my lap right now. Today we're doing intelligent design. And I wasn't sure what it was, but it turns out intelligent design isn't very intelligent. And we're going to get right into that. So let's see if anybody wants to join us. You can please say hello if you are joining us as I get this going. So welcome if you are new to this channel. I do all sorts of things in this abandoned building we're sitting here, and I'll show you some photos of that later. And I've got all sorts of videos on this channel about solar power, about how to survive in the post-apocalypse, how to do some cooking in the post-apocalypse, how to build this dinosaur that you see right here. That was a good cue. Oh, I wonder why it's not lit like it could be. Oh, there it goes. And so I've got like 20 videos that shows exactly how I built that. And she is being a little sweetie. I think she can sense it when we're about to have a live show. And she gets excited because she likes to be part of the show. Hello. This is Nebula, our special physics cat. She's very popular on the internet. Please like and subscribe if you're into this sort of thing. And the most important thing, actually, that's kind of new, and it relates to tonight's topic on intelligent design, is that I've written a book. It's called The Symphony of Entropy. And, ooh, I've got a special key for that, too, even. Wow, okay. This way I don't have to do that in post. And she's very excited, Nebula, to show us. Okay. Yep, we're going to have some fun, people. And so ODC, optimally dissipative configuration, is really the key to all sorts of things like intelligent design, why and how are we here. And it relates to all of our belief systems that usually are pretty much human-centered. And as we know, humans are not the center of the universe. So if we want to find the truth about everything that is, was, and will be, how and why we are here, and are we alone, we kind of need to zoom out the camera and kind of look at it from a point of view where if aliens in a different galaxy were looking for the truth about the universe, would they agree with our belief systems? And they would obviously come to the conclusion that our belief systems are based on humans. So humans make up stories, and then humans follow these stories, and it's a positive feedback that's absolutely necessary in the evolution of these complex structures that we call human beings. However, it isn't the ultimate truth of the universe, and I'll get into some detail as to how and why ODC solves the questions of intelligent design, and we're going to get into it. So welcome if you are new here. Nebula, maybe she doesn't want to move, but we're going to have to move around. You want to go play with some ping pong balls? She is crazy. She is very popular on the internet, but we're going to have to stand up now. And if you have any questions, I would love to answer them and discuss them if you like. So let's start out and go to our wall. And sorry, Nebula, I'm going to get up now. Okay. We'll go by the fire in a little bit, okay? So with my special handy-dandy tablet that I'm carrying here, you can see that I can monitor the chat. I can control different things that you see here. So this is what we call the atomizer. And we're going to use it today to demonstrate some of our principles of ODC, optimally dissipative configuration, and how it relates to intelligent design and the intelligence of the universe, and how that relates to the intelligence of human beings and our belief systems. And so to illustrate, we have a vibrating table here with many, many ping pong balls. They're all separated right now, and we've got a couple of shelves with some more ping pong balls here. At some point in today's video, we're going to turn on this mechanism, and it's going to seem like chaos. It's going to seem like it's out of control, it's unpredictable, it's chaotic, but actually, well, it is to us because we can't exactly predict what's going to happen. And 30 seconds later, this is going to look completely different, and it's going to seem chaotic. We might say that some intricate structures will be formed, and we might say that it's lucky or it's unbelievable, but they're actually going to do exactly what they're supposed to do and create very intricate structures that have never been created before or be created again because of chaos theory. But they're still going to follow the laws of physics and do exactly what they're supposed to do. So some of these ping pong balls have magnets on them, and that's going to allow them to configure with other ping pong balls. And what I've added in tonight's video, and you can see here how I can kind of monitor everything that we're doing, including the chat. And there's apparently nobody here. And what's funny about that is that people ask me sometimes, how do you stay motivated? What keeps you excited to do this when there's nobody seemingly either interested or know about it or watching your video? Well, you've heard people that have a passion for what they do, and this is what I have a passion for. I would do this for free. I do it for free. And I think it's huge too. We're on the precipice of a revolution in thought, and this is the very start of it, where we can finally now have real answers to how and why we're here, and are we alone? And it's a fun thing to do also, because look at this. I've got some mouse straps, 2 of them up here, and they're set up so that if one of these ping pong balls, when we do this chaotic thing, ends up setting off the mousetrap, then it's going to set up a whole new system of unpredictability, which is analogous to anything that happens in the primordial soup, where you have positive feedbacks and end structures that were unpredictable, and yet they're doing exactly what they're supposed to do. And this is going to relate back to intelligent design, because ultimately any organized structure that you see exists because it is able to produce entropy more so than not being in that configuration. So that's the short form of the answer to the big mystery as to how and why we're here. Anytime you see a big complex structure, and what I'll do here is, hopefully I can stop this video when it gets on this board here, and I can show you what I mean by these complex structures that, ooh, I should have combed my hair today. And looks like the camera's not gonna go there. Maybe one more. And so the idea is that how do these intricate structures appear if we know that we built all these amazing things that you see, for example, in this studio right here. Humans have built, and it's amazing what we can do. And so the big question is what intelligence created us? And that's where people historically kind of get stuck on, because we can't solve that riddle. And the reason is, and we're going to discover this today, is that we're still kind of centered on ourselves on this planet. And I will illustrate today how our thinking, even though we know that the Earth is not the center of the universe, if you imagine 8 billion little humans on this planet here, our thought life is very much kind of stuck to the Earth. And if we want to bring, like, let's say, a rocket ship out of the atmosphere of this planet, it takes a lot of energy and fuel. Similarly, in our thinking processes, it takes a little bit of digging and a little bit of open-mindedness to realize that we're not that. By finding belief systems that are not human-centered, we can get to the truth of things. So this is the diagram that you'll see on your book, the Symphony of Entropy, available at Amazon. And it's cool because I can press these buttons here and I don't have to add them in the post-production. And so if we go back to our diagram here, this is a general formula for entropy, basically saying that over time, the entropy of the greater system always increases. And what happens is this represents the Big Bang going to ultimate entropy, where where everything is dispersed in trillions and trillions of years, and everything is so vast and separated that we don't even have a concept of time anymore, because there's no incident or configuration to compare any other incident or configuration with any other, and therefore there's no more time. And so that's an interesting way. I've got a kitten right here playing with, I wonder if we could see that. That is so cute. All right. Okay, so we'll come back to the atomizer and make that work. Let's go to the fire pit, why don't we? I think that's Nebula's favorite, so we're gonna try that now. Here we are at the fire pit. Again, you see this dinosaur behind me. I've got a bunch of videos that shows how exactly I built that. All right, this is gonna be, this might be dangerous here. Oh boy. Phew. Yeah, am I right? Here we are at the fire pit. And so checking the chat, nobody is with us currently. And that's fine. This means I can talk about anything in the world. So I actually looked up intelligent design today just to do some background research. And it turns out it wasn't really what I thought it was. I thought that maybe intelligent design meant that we've got some answers that are intelligent as to how and why we're here. But no, it turns out that the answer to intelligent design is basically when we have that analogy of the fact that humans create these very intricate things, such as airplanes, 747 airliners, that we'll get to in a second on how I ended up solving this riddle through ODC, but that, okay. So because humans build these intricate structures, and we know that we're intelligent beings, that what created us has to be an intelligent being also. So it's kind of short, narrow-sighted. It's very logical, it makes sense, and it's kind of an old way of thinking, but today we're able to zoom out the camera a little bit more and more intricately understand that our being here relates to the entropy of the universe. In other words, the most successful living organisms, the most complex, we call them optimally dissipative configurations. Bam. That's fun. Are the ones that create most entropy. So if you think of the human impact on the planet as it relates to the dissipation of energy, even the heating of the planet, we do that very well. We're not the only organisms that do that, and it's always happened throughout history. But the point is that the way that entropy increases with the optimally dissipative configuration is how these structures get created. It's how they go downhill, if you will, and we'll get that in a second. Let's go to the board. Again, I'm here for you if you have any questions at all. We're going to talk about this gentleman here, Jeremy England. He is a real physicist, and it's because of people like him that we're able to have massive discoveries and changes in paradigm over how and why we're here, because Jeremy England is able to look at the world in a way that's based on physics and laws of physics, which are universal in the universe, and find out how and why we're here because of that. So here on the board, we've got our airplane. This is an airliner. It's made up of millions of parts working intricately together that a human has invented. And so the big question is, if we invented this intricate structure, what created us? And indeed, the easy answer is to a higher power or a God or an intelligent being. And we know the truth today. So we have real answers as to how and why we're here. And the real answer as to why the airliner is here is because it helps this human survive and reproduce, more so than if the airplane wasn't here. This is how it spontaneously gets created in the universe. We don't have airliners that don't work or that don't get off the ground. Similarly, the human serves the universe in the way that it's actually dissipating all the food, all the energy in the earth. Let's say we found all this fuel in the past couple of hundred years, and this fuel dissipates, and as a result of all this richness, we build all these amazing cities that sprout up everywhere. And so these two diagrams here, this is a planet or an Earth that doesn't have life or humans. This is an Earth that does have life or humans. The reason the human is here is because it's able to dissipate energy more so than the planet that doesn't have it. And if we try to do this, watch what I have here. We're gonna have, this is our man, Jeremy England, and so he's the Michael Jordan of this channel, because he's what's spawned all these revelations that I've had and written my book. And here he says something very new and controversial, that life should be as unsurprising as rocks rolling downhill. And so that's a mystery that kept me up at night. What do we mean by that? And great. And so here I've got a ball rolling down a hill. So it would seem that if the universe is going from order to disorder all the time, how can it be that intricate things are here? It seems like us being here would be going against that. First, the second law of thermodynamics, that everything goes from order to disorder. This is what these are. The first law being that we can't create or destroy anything. Energy and matter only converts into other things, so you can't just create things out of nowhere. But back to this ball rolling down a hill. So how is it that us being here is like rocks rolling down a hill when it seems like we're actually going up the hill? And the answer to that is that if we zoom out our perspective, it turns out that all this potential energy that exists from the sun, from this fuel that's around us, from living things eating other living things, is that potential energy actually lifts the hill. It increases the height of the hill, whereas the ball has no choice but to roll down it and become bigger and snowball. And so that's the key. This is second nature for me. It might be new to you, and this is why I'm here to expose or to show what I mean by all of this. So now we're gonna have some fun and go back to, now we're gonna go to the, how about to the holodeck? That's fun. Let's see if that works. A lot of moving parts in this little system here, so it's kind of neat when it works. So I've got a bunch of fun videos here. One of them, actually, I mentioned the dinosaur behind me, and so it was made by just regular 3D printers, as you see here, by hand, and then covered with some sheetrock, piece by piece, about 120 bones at the end, made up of about 1,200 separate printed pieces. And this is fun. We've got a visitor here. Hi, yeah, this is your channel. Yes, it's all you. And so this was a lot of fun. Then I actually even made some animatronics with it. So I'm gonna stop this because I went too far. And let's have Sean Carroll talk to us for a second.
From useful to useless in the cause of keeping organisms like us alive. In fact, life itself may have arisen because of entropy. The early Earth had pockets of low entropy conditions full of useful energy, like warm alkaline vents on the ocean floor. But there may have been no simple chemical reaction that could take advantage of that energy, use up its usefulness, and allow the entropy to increase. There were, however, more complicated chains of reactions that could do the job. In just the right circumstances, an appropriate network of chemical reactions might find a way to sustain itself by tapping into the useful energy in its environment. Some networks might have become embedded in molecular membranes, the precursors of cell walls, and broken away from their point of origin, becoming the first living organisms. Maybe that's how life began, a complex combination of chemical reactions that figured out how to tap into otherwise unavailable useful energy.
So this is going to be a good segue. We're about to create one of these keys that he just mentioned, and we're going to head over back to the wall. But first, I'm going to show, oh yeah, this is the building we're in right now, and right now we're in this room over here where it all happens. And you see all the solar panels there on the roof. If I go back, maybe 1 second. All these solar panels that I make a bunch of videos about that also. So now we're going to go back to the wall and activate the atomizer and demonstrate how we're going to create this key and we're walking. You should be hearing some background music, and I've added that so that the live version could be a little bit better, but I'll take that out after I do some post-editing. So now we're going to activate the atomizer, and it's so loud that I have a special button here that I'm going to press. So keep an eye on how currently everything's separated and random currently, and in 30 seconds it should look very much different. And here we turn on the atomizer. Okay, let's some balls get out of the way here. And so not only did we find that we have some new structures here that have never been created before, because it's seemingly random, but for example, I'm going to hold this one up here. We talked about if there was a key that was able to activate what Mr. Sean Carroll in our previous video, this is an example of a random key that would form from randomness, apparent randomness. But if that was able to somehow set off another reaction, then this would be a positive feedback mechanism that would encourage this type of configuration to take place and hence evolve into other configurations. We're going to do this one more time, but this time I'm going to activate the mouse straps, which will introduce a whole slew of new configurations that can occur. And this is to demonstrate that once these mouse traps are set off, they'll never come back to where they were. And that's important because that's the forward movement, the forward motion of time that occurs when something optimally dissipative, because there's a lot of potential energy in those mouse traps, when that optimally dissipative configuration occurs, it's more irreversible, so it won't go back to where it was, and hence the forward movement of evolution and over millions of years that comes to things like humans and cats. Okay, and that was a fun mess. So now we have even more different types of configurations that occurred. And that demonstrates, if you have any questions, let me know, and we'll get to your questions. So, intelligent design, whoa, I shouldn't be moving until I move the camera. And let's go up back to the fire because it's actually pretty cold in here, believe it or not. So this building that you just saw is not actually heated. And so this is nice to warm up at. A couple of more things to maybe have fun looking at. You might have heard something called Luca. So this is our Meet Your Maker. If we go back billions of years, Luca is our longest universal common ancestor. And we can currently trace our origins and the origins of all lives to this particular thing. And so each year as we kind of go up in our evolution, I wonder why that's not doing it. So each year we evolve in our thinking and going back in years as far as where we came from. And science always goes towards more factual answers to where we were before. And unfortunately, what happens with belief systems, which are necessary for us to be where we are today, unfortunately, the belief systems usually have to evolve after the science finds out what the truth is behind our stories. And right, that can be controversial. There's a lot of even wars that occur over these types of things. And that's the unfortunate part of making new discoveries, that people might be offended because our human-based beliefs only go so far. And if you have any comments or suggestions about how we could do better with that, please let me know. But now we're going to the mezzanine. I think that might be the cat's favorite. We're gonna walk up here. And if you have any questions or comments, I would love to hear them, and I will answer them as we go. So there was a time when, if you ask any human, and this was only a few hundred years ago, and we're going to talk about Galileo right now, where obviously we knew that the Earth was the center of the universe, and the sun and everything else revolved around it. But then there's people that come along, and they have a telescope, and they take a lot of notes, such as Copernicus and Galileo, and they know for a fact, after doing what they do, that, oh my goodness, we're actually one of many planets that go around the sun. And in fact, we learned later after that there are also billions and billions of stars, and there's billions and billions of galaxies. And so where do we belong in all of this? And the world keeps getting bigger and bigger, and ODC, optimally dissipative configuration, embraces that. It's all about the fact that if we are here, it means that, or if nebula is here, it means that that presence creates more entropy or chaos to the universe than her not being here. And I think that's her favorite aspect of all of that. So if I press this button here, I can actually talk and make a presentation. So this is our man Galileo. And so what happens is that in his case, what he wrote about and what he discovered was actually admonished by the belief systems. Right now, as I sit here, I'm allowed to speak facts and truths, and people are encouraged to have their own truths and belief systems, but it's not always the case. And so, as a thought experiment, what if we take ourselves back to the time of Galileo, when our belief systems would be sure that we are actually the center of the universe, and somebody comes along with a telescope and shows us, or wants to show us, that actually the world is much bigger? What is our response to this? And so this is a question we can ask ourselves, similar to when a new model of thinking appears, like I'm currently doing. Then what is our attitude to be? Do we embrace new discoveries, or do we get angry? And Nebula, it's just me and her here. Maybe we'll just make some short videos. Hi, Nebula. Oh. Look at this. It's a fighter jet. It's a fighter jet. Yeah. What are we gonna do? What are we gonna do? It's a fighter jet. It's a fighter jet. Whoosh. You're out of the shot, kitty. You're out of the shot, kitty. It's the Imperial Force. All right, so we don't have any questions, I see, so we might start thinking about wrapping it up. And let's go back to the desk. So thank you for joining me, or in the future, what's fun is that people might watch this video 10 or 15 years from now and be like, wow, this guy had some answers back then, but, well, maybe he's not very good at making his YouTube channel be known also. But the idea is that we are on a forward trajectory to a whole new way of thinking, and I guess we want to ask ourselves, do we want to be at the forefront of this revolution in thought, or do we want to resist and let our other humans and other societies advance scientifically, and having other societies that don't embrace the new science and thinking, and then fall behind in the evolution of our countries and political systems. So, thank you for watching in the future. I'm talking to people in the future, and I will be doing this every Tuesday at 7 p.m. I didn't do it last week because it was Halloween, right around trick-or-treating time, and I wish you a good night.